Okay, ladies and gentlemen, let's take a look at graphing. Now, you were given this problem. Let's go through the various iterations. So, y equals x plus 2 from -1 less than x less than equal to 3. And so the graph would look as follows. 1, 2, going up 1 over 1, up 1 over 1, up 1 over 1. We have this area right here that we're going to use as our representation. Now, to rotate around the x-axis, simple rotation around the x-axis is going to be your easiest because it's going to be the classic disk method. So with that, integration from a to b of pi r squared d, and because we're going around the x-axis, it's going to be dx. Now, the radius here is pretty straightforward. It's straight up and down. So we're going to say from -1 to 3, pi f of x, so it's x plus 2, the quantity squared dx. And we're going to integrate that. Now, to go around the y-axis, we have another small problem. If I rotate that figure around the y-axis, I actually have this area here, and then I have this area here. And when I attempt to do this, I'm going to have either doubled over area or missing area in the volume. So if I'm going around the y-axis, the only thing that it would create is a cylinder on the bottom and this open container on the top. So what I need to do is I need to split it right here, because this portion will be a cylinder. So I can say integration of pi r squared plus another up top, but that's going to be a disk. So I'm going to need to find radius. Well, the outer radius the entire way is 3. Since we're going along the y-axis, we're going to use dy. Since we are going up top from here to here, the outer radius is still 3 minus the inner radius. And that inner radius is going to be determined by this function. But that function can't be in terms of x, it has to be in terms of y. So y equals x plus 2. So x equals y minus 2. So minus y minus 2. And that whole thing is squared. No, I take it back. It's outer radius minus inner radius, so squared and squared on each piece, dy. Now, bounds for the bottom portion, 0 to 2. For the top portion, 2 to 5. And so by setting this up, we have this portion that we can find the volume of, and we have this portion that we can find the volume of, and then add the two together to find the total volume. So that's what you have for going around the y-axis. Now, if we're going to go around the line x equals 3, well, x equals 3 is a vertical line. So we have here this shape, and it's going to be rotated around that axis right here. Now, the challenge here becomes, what is this radius when we go around? Now, since it's around something that's like a y-axis, so it's like y-axis, we're going to be using dy. So it's going to be integration, and it's going to be dy. Now, additionally, the shape itself is going to be solid all the way through. So it's a disk method, not a washer method. So all I need to do is pi r squared. Now, what's my radius? Well, if I start down here at the bottom, the total radius is going to be 5. Nope, I'm sorry, 4. because it goes all the way from 3 back to -1. So how do I get this value down here at the bottom? Well, the radius stops here. So I'm still, even though I have a cylindrical shell, it's a disc method, I actually have two parts. I have kind of the tuna can on the bottom, and then I have the cone on the top. So I'm going to actually have to do two of these. Pi r squared dy. Now, on the bottom, it's for the entire time from 0 to, well, where's this corner? 0 to 1. And so from 1 to 5, I have this. How do I find this radius? Well, it's going to be based around 3. And so I have originally 3 plus another -1. So 3 minus -1. So if I say 3 minus f of x, would that make a total of 4? Up here, if I have a total of 3, but I take out f of x, that only leaves this. So if I have something like 3 minus 2, that equals 1. So 3 minus f of x, that's finding the radius. Now, again, I put f of x, but it needs to be f of y. So integration from 0 to 1, pi 4 squared dy plus from 1 to 5, pi 3 minus y minus 2, quantity squared dy. All right. So with that, you can put those two together, and that's it. We'll continue in the next portion.